Hello everyone. Welcome. I'm your host and speaker, Mohammad Ali Thara. Thank you for taking the time to join us today as we talk about over the air that is OTA firmware update. In previous webinar, we met to get introduced to over the air that is OTA update, and now let us see how it works with actual demonstration. All right, let's get this show on the road. First, we will kick things off with a quick intro. Then, we will talk tech and explore the difference between the firmware and software updates. After that, it's time for some action. We will show you the two FOTA demos and finally, we will wrap up by talking about the challenges of updating medical devices. So in previous introduction to FOTA webinar, we explored the importance of firmware updates and why they are critical for maintaining the performance, security, longevity of connected devices. Firmware updates address bug fix, security patches, and enable new features, making these essential for adapting to evolving near user needs and technological advancements. We also discussed two primary methods for firmware updates. Those were manual and over-the-air firmware update. Manual update require physical intervention, offering control and thorough testing, but it can be time-consuming and insufficient for large fleets. In contrast, OTA updates streamline the process by remotely delivering updates via network connection, also for faster, scalable deployments. However, OTA updates require a robust network and stringent security measures to ensure data integrity. The OTA update process follow a structured flow including stages like preparation, secure transmission, validation, installation, and post-update verification. This approach minimizes the risk of device malfunction and provides seamless user experience. We even examined two types of OTA update. Those were full update, which actually replaced the entire firmware, and the second one was partial, which we call it as a delta update. And in this, we update only the modified section. Delta updates are particularly useful for reducing update size and saving the bandwidth. The key aspect of OTA update is the management of data partition. Proper partitioning ensures that the update process does not interface with the device's normal operation, maintaining a stable and reliable system. Next is the security. Yes, it is a crucial concern throughout the OTA process, requiring the use of encryption, digital signatures, and secure boot mechanism to prevent unauthorized access or tampering. Overall, a strong firmware update strategy, particularly leveraging OTA capabilities, is vital for keeping connected devices agile, secure, and optimized, enhancing user satisfaction and reducing operational risks. So, in the recap, what we saw a consolidated view of essential elements discussed in the previous webinar, underscoring the advantages of adopting OTA updates over manual updates. Here you can see that in case of manual update, the end user actually sends the product back to the factory where the firmware is updated manually using a wired connection. Once the update is completed, the product is repacked and shipped back to the user for further use. We even investigated the pros and cons of OTA update in previous webinar. The biggest benefit of OTA IoT firmware update is that you can continuously add new features, fix bugs, and improve the product behavior even after the device is in the end user's hand. While they are highly convenient for both IoT manufacturers and users, OTA firmware update also have some drawbacks with it. For one, they require the device to be working and connected to the internet, In addition, the device needs to be shut down and restarted in order to complete the update, which can be a problem for scheduling the upgrade. Let's see that is that only humans need update? How do we humans stay updated? One would consider reading a book or catching up with their favorite news channel. Keeping yourself informed is actually a necessity for survival, right? If we do not have the knowledge or information and tools necessary to survive, we will surely be left behind. It's just as important for our devices to update from time to time. Similarly, every device needs an update. As our device gets more sophisticated and complex, it's important for its operating system and underlying software to be kept up to date. Updates are scheduled at specific time when a device is deemed ready for such upgrades. This could be the developer adding new feature or maybe fixing some bugs or even improving the security. These updates are necessary to ensure the performance of the devices. In case of IoT devices, it would be nearly impossible to rely on something for updates as there are many devices used at a bigger scale. Before moving further, I would like to sh- give you a poll question, and here's a first poll question for you on your screen. I'll give you 30 seconds for this. So the question is, what types of update does your organization currently perform most often? The options are firmware updates, software updates, both equally, or you do not use OTA updates at all. You have 5 more seconds to answer it. And I can see most of you have answered the question. Actually, the answer depends on your organization's current practices. So here you can decide. For example, if your organization is primarily updating the firmware, which we call it as low-level software controlling hardware on your device remotely, then of course you can go with the firmware update. But suppose if you primarily update the application level software on your device, for example, user facing apps or features, then you can go with software updates. And but if your organization updates both firmware and software at similar frequency, then firmware and software update are required together. And the last option is we do not use OTA updates. So I would recommend to at least have one type of update so that you can be with the world. Let's deep dive into this more and understand more about firmware over the air update and software over the air update. Firmware and software are two different components that might seem similar but serve distinct purposes. Firmware is actually the hardware specific version of your computer program, whereas software is the broader term that refers to the instructions that tell your device what to do. Especially, firmware is the code that allows a device to control its hardware and communicate with other systems, managing tasks such as memory access and interfacing with peripheral devices. In contrast, software includes all types of programs, applications, and operating systems that run on your TV. Let's take an example of smart TV to illustrate the difference between firmware update and software update. Firmware updates for smart TVs often execute through FOTA update, which we call it as firmware over the air. It can enhance the color profile, improve the efficiency, add new technical features to it. But FOTA makes it possible to perform these firmware updates wirelessly without requiring any physical connection, which is actually a game changer for modern smart devices. That is what firmware update means in a practical context, updating the embedded software that controls hardware functionality. Speaking about the software, On the other hand, software updates on a smart TV might include changes to user interface, updating the downloaded apps, or maybe a new feature added to your TV's operating system. While firmware updates are less frequent, they are actually crucial for overall functionality and security of your device. FOTA technology ensures that these firmware updates are efficiently delivered, keeping devices secure and up to date. A FOTA update can also provide critical bug fix to the operating system of a device or introduce brand new features, significantly improving the performance and extending the device life cycle, which we always like to have with us. In contrast, software updates are generally more frequent and revolve around more making improvements to the application, patching security flaws, or optimizing the performance. I would like to give you the demonstration of over the air firmware update. So what we'll do, we'll have one quick OTA update first. So in this demo, we will see how over the air firmware update happens. I have an ESP32 board with me. So we are going to use an ESP32 board. And in this, what I will do, I will use async elegant OTA library. This library creates a web server page that allows you to upload the new firmware to your board without the need to make a serial connection between the ESP32 and your PC or maybe a computer. This is how my ESP board looks like. And actually, there are different ways to update your uh, board, and which we call it as OTA firmware update. But in this demo, what we will do, we'll cover using an async elegant OTA library. In our opinion, this is actually one of the best and easiest way to perform the OTA firmware update. And speaking about the async elegant OTA library, it creates a web server that we can access on our local network to upload a new firmware or files to the file system, which we call it as SPIFFS. These files should be uploaded in the form of .bin file that we call it as a binary format. I will show you how we are going to create the binary file and how we are going to use it using a browser and created web page. Before that, I'll tell you what are the steps we are going to follow. So this is must we need to do. The first firmware what we are going to upload is through serial port. We call it as a default factory firmware. This firmware should actually contain the code to create the OTA web updater so that we are able to upload uh, new code later using your web browser. The OTA web updater sketch creates a web server and we can access to upload a new firmware via a web browser. Then we need to implement the OTA routine in every firmware we upload so that we are able to do it the next update or upgrade over the air. But we should keep in mind if we upload a code without an OTA routine, then we will no longer be able to access the web server and upload a new firmware over the air. So this should be kept in mind. So this is how my board looks like. I have connected it to my PC. As I told you, it should be a wired connection as because we are going to have a default factory firmware first. What I'll do, I'll show you the firmware what I'm going to put into it. So this is the first firmware. As I told you, I have an ESP32 board with me, but of course you can use ESP8266 also. And we are going to use elegant OTA library. This will help us to create a web page for our OTA update. I have entered my Wi-Fi credentials here. This code does nothing, but it has a basic page, what we call it as a front page. I'll show you how it is going to look on our web browser. I'll demonstrate that. And after that, we are going to start the elegant OTA web server. I'll tell you what we are going to do in this code. Uh, what we'll do, first we'll comment this code actually. And what this code does is it will blink the white LED at an interval of 1 second. So just a simple demonstration, but this will be a wired connection. So I have already compiled it for us. I'll directly upload it on our board. But before uploading it, it already compiles and then only it uploads. So we might need to wait for a few more seconds. I'll just tell you that I'm using ESP32C6 development board here. So you can select it under the tools, under the board section. We can select an ESP32 board here. And of course, on the port what we have connected our board, we have to select that. Okay, it's still compiling, creating the library files for it. So once I'll tell you that once this is done, once we have uploaded the code, we need to have the IP address to which our board is connected so that we can access the web browser. And yeah, it's writing and it's done. So what we'll do, we'll see the IP address to which board is connected, and it is 192.168.3.100. I'll copy it for you. So we'll go on web page. Before going there, what I'll do, I'll show you how our board look actually here. So this is a wired connection. In this video, we can see that a board is having a wired connection with the PC. The firmware is getting uploaded, and once it is uploaded, as I told you, we are having a white onboard LED which will blink at an interval of 1 second. So yeah, it's almost done, and you will see a white LED. Yeah, so it's blinking, right? But this is just a simple firmware which we uploaded through serial wired communication. And now we can see a web page as well. I'll show you. Mm, yeah, I'll paste it. So yeah, this is the front page. We can see, hi, this is Decos over the air firmware update. And let's try a FOTA example, right? So what we'll do, the same code will take as a base, and I'll off the serial monitor, uncomment this lines. This is the same code base what we used for earlier purpose. I told you that we need to have a bin file for OTA update. So what we'll do, we'll just uncomment it and use this code as a binary file. So what I've done to save the time, I have already created a bin file of this. I'll show you how we can create it. Of course, we need to compile it. Do not upload it because we are not going to have a wired connection. Just go to Sketch. There's an option, export compiled binary file. So what it will do, it will create a bin file for you at a place where you have created your project. So this is already done. What we'll do, we'll directly go on the browser and navigate where we have kept our binary file. So the thing what we have to do is an extension saying update. So it will go here, and this is the web page what is created using an elegant OTA library. What we'll do, we'll select a file under this. I'll just navigate where I have kept my binary file for us. So this is the binary file where I have kept it. What this binary file will do is blink onboard LED in the form of RGB, that is red, green, and blue. So let's select it and the upload will start automatically. So what we'll do, we'll go on board and see how the LED blinks. So this is the previous white LED which is blinking, and you can see the board is connected to power supply and not connected to the PC. So the code is done. Yeah, it's uploaded and you can see the LED blinking. So white first, then red, green, blue, off. Again, white, red, green, blue, off. So this was just a simple demonstration of OTA update wirelessly. But this was very basic one, and of course we need to have some other demonstration. As I told you, I'll show you two demos, right? So let's go with the other demonstration, which we call it as secured OTA update. There are many ways actually to have a secured OTA update, but just as a for demo purpose, I'll have a simple one again for you. So after using a basic simple library of elegant OTA, we are going to try another example. Security, yeah, of course, it's most concerned topic, right? While dealing with OTA updates. So in previous demo, what we did, we just saw that one can directly upload a file and update the firmware. But now in this demo, we shall have some additional feature of security, which we call it as a login page. So then updating the firmware using this login page, it will prevent the product from unknown user to upload the firmware directly on your product. I'll show you how the web page looks like I have created. This will be the Decos login page. It will help us to secure our product for from unknown user to upload the firmware directly. I'll show you this also how by a demonstration. So before going ahead, what we'll do, we'll see a code for it, how it looks like. So what we did in previous firmware was that we were using an elegant OTA library. But here what I have done, I have not used any specific library. These are just the common libraries available with the board. I have included those. Same Wi-Fi credentials as required to which we are going to connect our board. And this is the login page for security purpose. I have added here the code for this. And yeah, what we'll do, we'll similarly create a binary file again and try to update it over the air. So same process, we have to go under export compiled binary file and create a binary file for us, which we will be using for OT update. So again, to save time, I have already created this binary file for us. So let's go directly on the web page. We need to click on back. Same process, select file. Let me try to navigate where I have kept my binary file, and it's under this OTA web. So this is the OTA web.ino.bin file. We are going to use it. So let's select it, and yes, it's getting updated. Few more seconds. 100%. So update is successful. The best part here is that we do not need to reset our board directly because we already have an automatic circuitry on board. So the board is already getting up, rebooted. So what we'll do, this is the IP address. Let me refresh it. Yeah, this is the login page, what I showed you before. It's a Decals login page. So we can only enter on the next page when we enter the credentials correctly. So these are the credentials. Let me log in inside this. Okay, so this is the Decos update page, what we have created for us. And we can now choose a file from here, update it so that a new firmware can get updated. So let's have one more demonstration here for this page. So what we'll do, we'll again take a same code base for us and add a simple code. So I'll show you the code. So this is the code. Uh, as I told, it's a same normal included files, credentials, and as I told you before showing the first demo, that we need to have the OTA routine into it in every firmware so that we can have a new update every time. So this is the login page for security, a normal DCOS update page for us. And what I have added in this is additional other, all things are same. Same onboard LED, white LED blinking at an interval of 1 second. So we'll create a binary file for us. Same process, go under sketch, export the compiled binary again, and I have already created for us. So what we'll do, we'll go on the web page. So yeah, this is the web page. Let me choose a file for us, and it is under this OTA web LED. And yeah, this is the binary file for us. Let's directly use it. So what we have to do is click on update so that the update starts directly. Let's go on the board how it is showing. So this is board and it is connected to power supply. Okay. So the previous code was not having any LED blinking, and now we are going to blink an LED at an interval of 1 second. Yeah, so this is white LED blinking at an interval of 1 second. So this was just a simple demonstration. So what we saw was first the normal demo using a binary file. We tried to have an RGB LED blinking, and then a secured way by having a web page, login credentials, and then blinking a white LED. So yeah, of course, these are very basic OTA firmware update examples I have showed, but of course, we are very good into it for your service. So let's have one more poll question for you. I'll give you one more poll question on your screen. Again, similarly, you will be having 30 seconds. And the question is, how often do you typically update the firmware of your connected devices? Options are monthly, quarterly, biannually, annually, or there is no fixed schedule as per the need. Okay, you have 5 more seconds. Hurry up. Okay, yeah, time is up. I could see many of you have answered the question. Speaking about the answer, there's no single correct answer again here, as the idle frequency depends on the device type or maybe the industry and specific use cases. Uh, but still, let me try to help you with the answer. Quarterly updates are often preferred for balanced security and minimal disruptions. But if you are going with mission critical devices, for example, medical or financial systems, then you may need monthly update. But while consumer electronics are there and industrial devices are there, then they might opt for quarterly or biannually schedules. And again, speaking about the long life or legacy devices, then they may need a annual update. But if your organization doesn't follow a set schedule, then implementing a regular update cycle is crucial for maintaining performance and security. This was all about the schedule, about what I told you. But of course, when it comes to an instant update due to maybe some major bug fix, then push update, which is called is patch update, is needed. And this has no schedule, it is directly updated instantly. Let's speak about the complexity of medical device update. So updating a firmware for healthcare device might sound simple, but it's anything but what we call it as a legacy system. These they often don't play nice with modern update, leaving around 35% of devices stuck in the past and vulnerable to the cyber threats. Then there's the regulatory nightmare, right? Getting the approval for updates isn't just a small hurdle. It can take anywhere from 6 to 12 months to get the green light from the approvers. It can take anywhere a very difficult time, which might uh, skip your important fixes, and improvements are also delayed far too long. But the real headache, though, is the resource needed for the manual update. So hospital end up pouring thousands of hours and millions of dollars into trying to roll out the update globally, which is actually a huge drain on their already stretched IT team and budget. And when you throw the IT fact about the IT teams, clinicians, and vendor, they often aren't on the same page. Smooth collaboration becomes near impossible dream. But the real cost is patient care. Even a 15-minute downtime during critical update may not seem like much, but it can put your lives on risk. On top of that, when devices are outdated or malfunctioning, it can lead to serious issues like medication errors, failed treatment, and a whole lot of other problems that no one wants to deal with. And that's why there is no surprise 40% of healthcare providers hesitate to update their device in first place. They fear the risk that come with it. This is where we come in as a because we have got solutions that make firmware updates seamless and worry free. We make sure everything is compliant, secure and built for needs of today's healthcare world. Let me tell you more about our services in detail. We have been in software and healthcare game for over 20 years, helping clients all over the world building new products and keeping the old ones running very smoothly. When it comes to firmware, we are all about into it. Building custom firmware, so we create firmware for embedded systems that are small and mighty, perfect for the devices with limited resources. Over the air updates. So here we make it easy to update your device wirelessly. So you can add new features, fix bugs, and keep your device safe from the hackers. Of course, security. It is first. We build security into our product from ground up, protecting your devices from harm. Then there is driver development. So we write the code that makes your hardware and software work together seamlessly. RTOS, real time operating system. So we know how to make your devices work efficiently and respond quickly for your products. Hardware software co design. We work closely with the hardware engineers to ensure that your firmware and hardware work together perfectly. When we talk about the development, of course, testing and validation come hand in hand. We put our firmware through rigorous testing to make sure it's reliable and work as expected. Custom bootloaders. So we create custom bootloaders to ensure your device start up quickly and reliably without depending on any other further needs. Protocol implementation. So we support a wide range of wireless and industrial communication protocols, diagnostics and debugging. Of course, we provide tools to help you to troubleshoot and fix problems with your firmware. So guys, that's all for today. I hope you like the content delivered and understand with the help of the demo how FOTA works. For any question, you can contact us. The contact details are on your screen. Please note a recorded version of this webinar will be available on our website within a week. We will also send you an email with the link on your registered email ID to access this webinar. Thank you for the time. Have a great day, guys.